Sir, two things, sir.
Ah.
Actually, in the first stage, automotive design, we already freeze the design of those things. So pipeline, everything, they are freeze and material also going to dispatch on February. So design modification is very difficult thing, one thing. And another one thing is there is no space to keep the tank. So for the tank, it is very oil separator. So that is also very difficult thing. So as sir, Prabhakar sir said, we have some separate satellite jumping in the ETP area itself. So as of now, we can't do changes in the plant inside the paint shop.
Okay.
ETP area, how we can do? We are mixing it with other effluents. It has to be separated because it is not. We are saying all the effluents we have to remove.
All the effluent is very oil filter in the bed, sir.
Okay, we discuss that.
Although it is like RE, we have to keep it like this from the go. It is also safe in RE. We don't have any separate oil skimmer in the paint shop itself.
I know. Hot water is not
Same
kept
thing.
to separate.
Area we'll discuss with you what the suggestion I will inform you again.
RE component and our dry component.
Okay, you can also check up them about the
One more
makeup.
thing, sir, when compared to RE, in the Aether is very small components. Okay?
I know.
The oil,
It
it
is
also
very
very less than that, very less component with oil. When
All
compared to
the
the
side parts are plastic.
other, yes, correct. Only 2-3 parts will be coming in the oil. So that is very
Tubular part powder is as a tube itself, tube supplier itself, we have got oil inside.
yes,
Even if there is there, so remove the inside.
yes,
Okay.
very easy to get.
I know it is not there. Hot water is not permitted also.
Okay, now I'll just
Being separated.
We can go.
I will cover it quickly.
We can have a separate ETP.
So can I?
We have regular discussion.
So volume of water will be high, no? Unnecessary will have space.
Sir, what we'll do is we will keep this issue and then we'll see how to address it. We will move so that.
For the sake of it, like we can include the DAP because we have to send this to our suppliers today. So like we have kept all the changes drafted. Yeah. So can you include the DAP?
Yeah.
Can you
What I will do is I will put a DAF here and then I'll put an arrow saying 4.5 KL hot water.
So
yeah.
Before collection time.
Yeah, before collection time. Yes.
But sir, hot water alone cannot
So does that
another range of hot water cannot be separately coming to the ETP. That is not feasible now.
Now,
Because all the trenches,
Okay.
all designs, very civil work has started.
no. My request is I have made my suggestion. Now, how to implement it is the next step. Okay. Now, I cannot make RO plant tolerate oil. So if oil is coming out, then it has to be separated. If from your experience, this doesn't matter, this may get separated even at this, then we can go ahead with that. There is no problem
But
because
in ETP one itself, we can think of that, no?
yes,
Correct, no?
yes.
Yeah, so after the flash mixer or after the collection time, we can add the DAP there itself.
Like yellow.
That's what I feel.
Because in CDs there is no oil. Dark is helpful for oil also, no? It removes oil.
Mainly I will.
As I said, we'll moving, it's already 20 minutes over, we'll cover the rest, but this is one issue which has to be looked into, so we'll note it down. Then the next issue will be how much should be the makeup water. I have given 15 KL as my experience. It can be STP treated water or raw water. Now, raw water means it will add to the filter feed, or in both cases it can be taken to the collection tank also. Suppose the raw water is not very good, turbid and so on, in which case it can be taken to the collection tank. Now from filter feed tank we go to ACF, PSF ACF, and for turbidity removal, and then it goes to UF filter, UF feed tank. Now we have suggested 4 module UF. The membrane can be any one of the 4-5 suppliers. Right now there are 10 suppliers in the market, and around 8 KLD will be the backwash water every day coming out. And from UF, it will go to the RO. I have suggested 2-stage RO system. If maybe a 3rd stage can be added later if you want to save water going to the evaporator. But in Karnataka, the projects where we have worked, what they have done is the 3rd stage reject water, they give it outside. I don't know what is the consent to establish condition in your case. So 2-stage water recovery, the 3rd stage reject or the 2nd stage reject can be given outside, or you can take it to the evaporator. We have suggested 12 membrane, 4 element into 3 numbers of pressure vessels, 12 membranes. 12 membranes will give anywhere from 6 to 7 in a conservative estimate, meter cube of permeate. And then to 4 element 2 numbers. This will look little
What is
uniform.
the first stage percentage reject and second stage percentage reject in what you have planned?
Yes. The permeate goes to the permeate collection tank from the 1st stage. The reject goes to the 2nd stage feed tank. And
The
then
recovery percentage
What is the percentage in first stage and second stage?
like 70-30,
If you feed 100, how much comes to permeate?
yeah, it's around 75 to 80.
In the first stage, in second
Yes.
stage?
In the 2nd stage, it's around 40 to 50.
Percentage. Okay, because it is higher concentrate.
Yeah,
The input.
yes. I have given 8 KL reject, but by operating properly, we can bring it down to 4-5 KL also.
Okay.
Now the sludge comes from the clarifier from here, from SBR. I didn't put the marking here. This clarifier will come to the it comes to thickener. I have to put the marking. I have modified another drawing, but only this drawing I have right now anyway. This is the only thing. This clarifier will feed here. The clarifier underflow from the high TDS will come here. Everything will come to a sludge holding tank. I have made it 18 KL. It can be increased depending on the plant area you have. And this sludge holding tank itself will work as a thickener, and then it will come to the filter press. I have not, it's slipped here. I will add the filter press here.
Is that the plating frame type filter press?
Yeah,
We can have a screw press also. That will be better. I want to eliminate manual operation.
Plating frame is not easy to operate.
yeah. You can operate screw press also. But let me share one of our experience. In couple of pharmaceutical plants where we have supplied decanter and screw press and filter press.
Okay.
Our experience is when it comes to biological, if biological waste is present, like STP waste or even this SBR waste is present, screw press work well. But if it's only inorganic waste coming, screw press, because screw press is a lot of perforations, it slips through the sides. So screw press works well with biological waste, very well. When it comes to inorganic waste, you have to mix with the biological waste and then only use the screw press. In our case, I am suggesting plate and frame, or if you want to go for a decanter, we can go for a decanter. Uh, the cost will be 3-4 times more, but decanter is no manual work involved. You feed it and then you will get it outside. So I would suggest here a decanter, or if you want to avoid manual, or plate and frame. In case some of you have an experience in this kind of inorganic waste and screw press works well, then we can go for screw press. See, the reason I am saying all this with with lot of caveats is lot of things depends on how you operate. When we have operated plants in Jigani, when somebody has totally given up this own work, so we went in and we operated it. So it's purely a question of understanding the equipment and then how you manipulate the surroundings so that it gives better result. I have added plate and frame. Yesterday night I forgot to add here. I think Neelakandan has not added here. I will ask him to add this, or I will put plate and frame. Okay, now let me ask your opinion. Would you go for a decanter or screw press or plate and frame? I have explained my position.
Yeah, so we have used in my previous company also decanter as well as a filter press. So filter press, I feel like there is a lot of manual work involved. So
Yes.
But of the surrounding will become dirty.
In case of decanter is so that gives a better result, but as you said, it is almost costing like not even 3 to 4. Sometimes it costs 6 to 7 times higher.
Yes.
So.
Yes.
So that
Actually, technically is not a problem. For example, in RE, we have given the phosphate sludge filter. Okay, it is a plate and frame only. Because this European they always plate and frame. But the quality of that equipment is excellent. Whenever the cleaning is done, nothing spills out. So Indian plate and frame filter press, in my experience in KS, it is all bullshit. I don't know about what you give, but in TVS, it is all because it all comes from the sides between the plates. Fitting. You have to keep one big tray below that. That tray should be having a slope on one side, so that the water goes up. All those things we have, and these are very heavy volume. I am talking about only phosphate tank, which is low volume.
Okay, so
But the RE plate and frame press is working very well. That is a European design, Geo design.
yes, sir.
What is the negative cost like if you go for the decanter, like even if it is like considering
Like the
High volume, no? Okay.
yeah, so filter press somewhere it will be around 5 to 6 lakhs, not more than that, but decanter will be like 35 to 40 lakhs.
Oh, because we have to allow.
Just you have to feed and collect itself, there is no manual, only you have to remove the bag.
Okay, I don't think say velocity also come down. No?
So that is like the centrifugal force.
Is a centrifugal
So currently we can add the decanter itself in the volume is kind of like let's see that there's a better benefit.
Okay, it is a
We add a
rotating.
decanter, then
I think decanter will be much better. So inside all of these things, the sludge will correct, outside they will permeate.
Yeah, so what will be come?
Okay, because we should not have manual operation much.
Yeah. So you can close that tab, that meeting will not close, that's okay.
Okay, now shall I proceed?
Yeah, so you can add a decanter there, but
Yeah.
from the decanter, whatever the recovered water, so we'll be sending it back to the sludge sorting tank?
No. That decanter will go to the ETP one.
Okay, so it will go to the collection tanker.
Yes. Because it may contain some
water, no?
Huh.
that will contain some turbidity
Yeah, so it will go to the ETP collection tank via drain.
Yes.
Okay.
See, in all these cases, in all these cases, you will have some floor washing some. Because if you do washing around the decanter, thickener, anywhere, some spillages happen, then they will be collected in one sump and that will be again pumped to the ETP1 collection tank. So this filtrate from the decanter can be taken to that sump also, which will be nearby.
Okay.
Now,
And
Yeah.
the 8 KLD which you are showing from the year state modules, where that goes to?
8 KL, okay, the RO reject.
No, the UF state.
This again goes to, this is the backwash washing, this will go to the ETP1.
Yes, so that again through drain will go back to
Yeah.
the ETP collection.
Yeah,
But you have to show it.
Yeah, we have to mark that
yes,
in the process.
Same thing, you have to make up
And,
you have to put both options, makeup or STP outlet, no?
yes,
No, it's an STD of that make up the order you pay here, and then you wait to the tank itself, collection tank. Okay, and you were saying like if we are going for a 3-stage RO, that the final reject, which you were saying that it can be directly sent outside, like what is that actually you meant? We add one more station RO?
yeah, the, what I have given you here, 2-stage RO.
Yeah.
So with 2-stage RO, you can get 95, 90 plus anywhere, because the last few percentages will be fluctuating. So you will, if you are going to have your own evaporator, then you want to even squeeze that further. Now, in Tamil Nadu, it is not possible. In Karnataka, you can send the reject water to common effluent.
That is in Maharashtra.
We have Maharashtra, sir. Yeah.
Oh,
and
okay,
then
okay,
in
sorry.
we cannot send it, there is
Sorry,
there is no
sorry.
affiliate which we can send
Yeah.
it outside of our.
Okay, okay.
Yeah.
Okay, okay.
They committed ZLD.
Yes, so that RO3, if we have that his point is that reject 8 KLD, that will come down. So it will be further reduced, so
Yes.
the load on the evaporator decreases.
Because the.
But whatever the reject is saying that has to be sent outside of the premises as a like drain. So that's
No,
what is not possible.
That is not possible. We can add that to the evaporator. So that is why that is the main intention of adding evaporator to take the evaporator.
You put RO3, input to evaporator comes down.
Yes.
And evaporators are normally costlier than ROs.
No, but in that case, why we need to send it outside? Okay, why?
If we don't
No,
know,
he is told one of
Karnataka, then you need a RO3.
one of the
Or evaporator.
Option, sir. That is one of option.
Yes. See, everything will be given in your consent to operate. Sorry, consent to establish. They would have given a condition. So we have to stick to that condition. See, we are working too many projects in Karnataka. My mind is always in Karnataka. Yes, this is Aurangabad, and I don't know in Maharashtra. I don't. In the projects we have worked in Nasik, Pune, and so on, they have not permitted. Everybody has their own evaporator.
Yeah, the same thing here. So
Okay.
we are also committed as.
Okay. Now, but I have one suggestion.
Sorry, RO
It's-
also there is evaporator, no?
Yeah, in Tamil Nadu, it is not permitted to give anything outside.
ZLD in Arias.
Yeah.
Yeah.
Now we can straight away have a 3rd stage here, or my suggestion would be use. You can see it will take at least 1 year for you to get this fully operational. And then we can see the capacity, how it performs, everything. Then we can go for a third stage.
Yeah, correct. Yeah, only maybe the space planning can
Yes.
be done the constraint.
Yes, that
We can
way.
provide space and have evaporator. Later on, we can
Yes,
add RO and then evaporator will be more efficient.
yes,
Correct,
yes, yes,
Shekhar?
Yeah, correct. Yeah.
yes.
Wonderful.
So, I mean, as much as you are giving me some information, I am using my experience. I see a lot of gap in the way you are giving me the information and the way I am perceiving based on our experience. What our field people are saying, like Chandrasekhar and Israel, yesterday you sent me a document saying the RCDM, that is the UF wash water from CED, is 50,000. Then you checked with your supplier yesterday and you said 4,000. In all the four plants.
I tell you the background, sir. I only got that information. Initially, whatever information they are given is based on the collaborator PPG from US. They are already normally on the safe side. But they are given based on the experience with one of their customers. Where it is not much high. They are given some 4,000 to 5,000. No? Because according to me, technically it cannot be so high. So
we have checked with all the 5-6 plants we are currently operating. Nowhere it is more than 1,000. 1,200, 800 to 1,200. That is where it is fluctuating.
That is too much optimistic, sir.
Yeah. But anyway, I have based on that only.
1% of the year 5,000, that is correct. Now they are given 4,000 to 5,000 instead of 40 to 50,000. So
Okay.
4,000 to 5,000 is okay. 1,500 is too much optimistic.
Okay, the reason I made that statement is it is better to go a little cautiously
Yes.
so that the assumptions we have made are validated, and then we can put our money for a better use later on.
They have given that revised value based on one of the customers where they are giving the paint, where actually the RPDM is lower.
Okay. Yeah, Prabhakar, you are right. Anybody who who supplies will be little conservative so that his area is protected tomorrow. Okay, now I have. Okay, I'll just take this.
It becomes small.
Okay, the permeate water collected in this tank, I have given 100 KL. Depending on the urgency of your process, you can have. Some companies would like to have 200 KL because they want the operation to be protected if there is any display here. That's purely a question of operational decision. And I have taken, if the volume comes to 80 or 90, I have made it 100 so that the tank sizes are uniform. That will make civil construction.
Why we are not taking any raw water? Because ZLD does not say you should not use raw water. Correct, doctor?
Yes.
Because in RE we are using raw water for treatment related water for culture. We are not using STP water. Am I correct?
No.
We are not taking STP water for treatment to paint shop water.
No. Okay. We have.
STP, why is that STP treated water going in RE?
To go for
RE has got your STP, I know that. So where is the treated STP water going in RE? Any idea? I don't remember.
No, you.
So everything is going to garden, sir.
Because I know very well that STP treated water is not going to for picture.
Okay.
I think they are.
It can be option both. We can give STP treated water, raw water, both.
Because my
Yes.
worry is STP treated water is good as a water conservation is good, but problem is anything goes wrong in STP, you have biological waste, that is what bacteria. That should not enter at any cost.
Hello, sir. Hello, sir.
Okay, that's okay, that we can use.
We can use,
That's
sir.
that's not debate on that, but anyway, option is there for both of them. So we go further.
Okay, now this permeate I have given 100 KL, and then it goes to permeate RO. That is, this permeate will contain say 100, 120, maximum 150 TDS. So instead of feeding directly to DM and MB, this water can be fed to permeate RO, which is a 3-vessel 4 membrane, and the permeate coming out will have around 15 TDS. That 15 TDS can be given to, I have given only MB. In the revised drawing I have given DM also, so it will go to cation, anion and MB skid. Now if you do this permeate RO and then feed it to DMMB, your quality chloride slip, or your quality is assured, no chloride slip will be there. Your operation before regeneration will be around 15 to 20 days, even 1 month, depending on how much we operate. And this way you will have a fairly steady operation. And since you have to go for evaporator, if you feed directly the permeate into DMMB, I have to add DM here, DMMB, you will be regenerating almost every other day. That means 100 kg of salt will be generated unnecessarily. So here you will be saving that, your load on the evaporator, everything. So this is on the process water side. This is the ETP area, and rinse water treatment and recycle area. And this is the high TDS area. In high TDS we collect, I have given 38 KL or 40 KL as the collection. Now the dump, I have revised it. It is 12 KLD. I have given, no, it is 3 KLD based on the data you gave me yesterday. So it will be 3 KLD and the reject will be 8. So the high TDS water, 3 KLD itself is on the higher side. I get only 1.8. If you add weekly everything and say divide it by 7, monthly everything divided by 7, it's not a big volume. But the collection tank will be here. Now I would put, I am going to add one more collection tank here for reject. Initially I thought I will take the reject and the dump in the same tank, but I will keep it separately. The idea being, once you collect the RO2 reject, if you have free time, you can even run it again and collect more water out of it by recycling. So that way your recovery will be higher, and then you can pump it to the high TDS collection tank. There you will, when you do sodium hydroxide, a lot of things will precipitate. Then once you do the clarifier, then it comes to the evaporator feed tank. From there you can give it to the evaporator system. The condensate.
Evaporator capacity, like how much we can give to 8 plus 3 meaning 11 kg. So I think 1 meter cube per hour is more than sufficient in our case then.
Okay, in the case of evaporator, the shell and the tube type evaporator, shell and tube type evaporator, your capacity will be minimum 25 or 30 KL. It is difficult to design a system lower than that capacity. And we have one evaporator which can work lower than 20 KL capacity. I will share that with you later on because that's not the purpose here. Say when you have a higher capacity, let's say 20 KL, not 20 KL, 30 KL evaporator shell and tube, you can operate once in 3 days. Sorry, 3 days a week, 2 days a week, like that, if your collection of evaporator feed is lower. So the
In our case, like what would be the exact needed capacity? Based on that, we can size it.
see, my estimate about your per day evaporator feed will be 11 KL. This is my estimate. Okay. But if you go for shell and tube, their design is for 30 KL. And the reason we have developed our evaporator, which I will show you later on, is majority of the customers I am working with are around 100 KL effluent people. For them, the stirred tank evaporator will be easy and no manpower is required and no cleaning, nothing. And for the pharmaceutical customers, we work with two major customers. One is pharmaceutical and Mylan is our major customer. There in Hosur we have given our type evaporator where it is lower. In Krishnagiri, where we commissioned recently, last 1.5 years back, they have gone for shell and tube because the evaporator volume feed is around 40-45 KL. Our system will not be efficient there, so they have gone for that. So that you can decide.
So for our requirement, you can suggest what is the capacity and what is the type of your.
Okay, I will share that evaporator with you if it's possible here. Okay, this is our type of evaporator. Okay, this is the jacketed vessel.
Small isopropyl for hot water. This tank alone. Because what normally suggesting isopropyl we need it, the quantity will be high, unnecessarily big isopropyl.
Yes, sir. Okay.
Shall I proceed with this? Just 5 minutes.
Yeah,
I'll proceed.
okay.
Okay.
Sure.
This is our type of evaporator, where there is no tube. It's a vessel SS316L, and you are stirring it, and there is a steam jacket outside. And in the normal evaporator, the main failure happens in the circulation. I will show you in the other schematic. In the circulation of the hot salt water. In this case, the motor is away from the hot salt solution, so there won't be any problem. This has been running in Mylan near Hosur, Ashok Leyland Plant 2, for the last 8-9 years.
Okay.
So this is the schematic. This is the inside of the evaporator. This is the salt you get from the bottom of the evaporator. This is the one which was implemented in RE first, and now Hosur. This is how it looks. It doesn't require any manpower to operate. It will operate by itself. It will feed by itself with the level sensor.
So you're telling that descaling is not required in this one?
No, nothing. Because there is no scale forming. Everything is circulated and it is open. The moment you feed, it will dissolve.
Is it something like that you have designed and patented from your company? Or
Okay.
It is a common this thing?
And here also no condenser is required. We are using air condenser. This is the plant in Upasana in Chennai. Okay, I will answer that question about patent. We have developed around 12, 13 equipments, but we don't patent anything because the first reason is patenting is costly. Second is it is very difficult to implement patent in India. If somebody in Aurangabad or Ludhiana copies, I cannot go chase them. So I have learned after a lot of discussion, patent is only between two big players. Small players can be easily copied. I don't want to give anybody anything, but anyway, that's the reality. So what we normally do is we keep improving. So anybody who wants to copy is always one step behind us. So that is the way we keep working. We are doing a lot of projects for Pfizer in US through a company called Geosyntec. There we give the patent rights to them and they pay us and they buy the whole thing because it's very difficult to implement, monitor the patent. That's very costly. But I had recently, we are working with IIT on 2 projects and they are interested in patenting because it adds to their credentials. For me, it will be a big liability to implement the patent. And the most important thing is when I patent something, I am revealing a lot of information. So this way, it is better to walk faster to escape a thief than by any other means. Anyway, now this is the normal system where you have a calandria here and it is getting circulated with a circulation pump. The circulation pump will be the number one problem because it will be dealing with the mechanical seal will be dealing with 140 degree or 130 degree salt solution. The number 2 disadvantage is the manpower. Skilled manpower, 2 persons is required. And the calandria type is designed for, I said 40 KL, even 30 KL you can go for. It's because the pipe size cannot be less than 1 inch. Too smaller pipe size will create choking problem. So this is the typical drawing, what I have taken from, this is the circulation pump. The circulation pump will be the main problem. Once the circulation pump starts leaking, your circulation through the calandria will be low, so deposit will take place. So this is a letter we got. In fact, this letter triggered us to in 2013 to develop our evaporator. They said less than this 20-25 KLD is very difficult for them. So then since many of our customers are on the lower side, then we worked on it and we developed this. Okay, these are the various other comparisons.
So with respect to the conventional one, so this is cheaper?
50% cheaper.
Okay, so you are telling RE also using the same system, right?
You know, initially they had the system, and then some pressure was brought out by pollution board, and they. Okay, I cannot say that. Okay, initially they had the system, they have no issues, problem, all the photographs.
Your system was there.
Yeah, there was no problem, but then some other pressure was brought in and something happened. I don't want to go into the details. But if you, currently you can see the system working in Hosur, Mylan, it's a pharmaceutical company. But recently we tried bringing one customer to them, but they have some labor problem. Somebody comes and surreptitiously taken some photographs, but we can see whether we can discuss with them over phone. But this is no fouling, so no cleaning solution, no extra manpower, everything is completely automated. It will work 24/7 and no mechanical seal issue.
Okay. What about the consumption, steam consumption? Is it the same compared to the normal one, or it is lesser?
Yeah,
The calendar, how is this?
by having two vessels, that's the one I showed you before. By having two vessels, we can have steam economy, which is same as Calandria type. See, the steam generated from one will be feeding into the other. See, this is the steam feeding into this second vessel.
Yeah, that's okay, but in the consumption, whether it will be higher or lesser compared to the calendar?
It will be almost similar.
For same capacity of total
It will be a
capacity,
Calandria,
which is
Calandria and this thing that, see, the steam consumption will be similar
Okay.
because the steam consumption is directly related to number of stages. So for first two stages, whatever the Calandria efficiency you give, you will get it here. Now I will collect the data from Hosur. In fact, we are going to do auditing. They are asking us to come for auditing anytime. So we will check with them and collect the data, and I can share with you. See, unfortunately, earlier people used to be very open. These days, a lot of political issues come, so people are very reluctant to share openly. So I can collect the data and give you. So in which case, it should not be a problem.
Okay. Okay, you can share with us.
Yes.
Later. Like I'll also
Yeah.
go through this once and we can have a discussion.
Okay.
And so coming back to the flow,
So what is the temperature of evaporation?
Pardon?
What is the temperature in the evaporator?
The evaporator, see the evaporator, no, the evaporator temperature will be normally 105 to 110 degrees, say 107, 108, like that. Normal evaporation. So after we reach 12% of the salt inside, then we stop the feed and evaporate it up to 45% salt, and at that time the temperature will be around 140 degrees, and then we dump
So
the
steam is a must.
yeah.
Steam generator.
steam. It works only with steam. Now I know why you were asking. I remember now you have mentioned thermic fluid.
Non-ideal.
You have mentioned thermic fluid as a heating medium, right? The evaporator.
Yeah, but thermic fluid, we thought that we'll go with that, but the issue with the thermic fluid, the few plants I visited, so they're telling there's an issue of SO2 emission from thermic fluid.
Absolutely.
Correct.
That's what I want to say.
Sorry.
Not only that, you will have problem disposing the spillage, disposing the liquid, and the degradation of the thermic fluid. All those things will be there.
Comes under tire,
So it is better we go with the non-IBR,
Yes,
the Revomax,
Yes.
what we have shown.
yes.
Flexible effect.
Yeah, on idea steam generator.
Less than 1000 kg, it is all Yeah, so one thing that can you add that DAP system?
Yeah.
So another suitable capacity to that.
Yeah, before evening I will send all these things to you.
Can you give today also?
Yeah.
Hello?
Yeah.
So actually we have to float this today. So the thing is like our civil construction has been at a fast pace now. We have to float it to meet our requirement. We were waiting for this from Monday actually. So we have
I
to
will send
float
it to
this
you
and-
by 4 o'clock. Mudiyuma.
Okay, so whatever the changes that we have discussed now, adding the gas system and connecting the little bit flows and all that, you can make it and you can send it to us.
So don't
Okay.
give anything vague. Please complete.
No. There is nothing vague here. The next step from this is the detail engineering.
Yeah, so the meaning once we float it, I mean, once we select the supplier, then only we will step into the detail engineering. Right?
Yeah, that is the that's the job of the supplier. Okay, now I will fill it up whatever we discussed,
Yeah.
and then I will add my comments about makeup water, raw or STP, whatever, and I'll also mention very clearly that oil should not go past clarifier.
Oh, but we are now adding DAP, no?
Yeah.
So,
But that is
so
a
you please add DAP, don't mention oil
That's-
mineral design, because as of now, we don't know whether we can have a separator and all those things. So you add DAP, so that oil is removed,
okay.
like in RE.
Okay.
Okay?
Yes.
Notice the makeup quarter quantity we know, right? So the further subsequent system capacity is based on that also, right?
Yeah. So one more thing, sir. So that makeup, adding the makeup water. So like now we are telling 110 KLD of 110 KLD capacity. That is almost 6.8 meter cube per hour. You were telling. So can we increase that a little bit? Because like so whatever the non-daily effluent we are receiving. So if we open the non-daily effluent.
That is why. One minute, listen. That is why we have RE and DAP. I know that is only I told you, difficult to implement now. So we have RS and trying to
Continuous.
Yeah, this is the non-daily effluent.
Non-continuous.
Very well done. He is going to add DAP.
So if you see all these quantities, so whether 110 KL capacity, 110 KL, whether will be sufficient or do we need to increase the?
That is what I.
Now here, see,
What I told. At this stage it is difficult to add. So please add DAP video portion. He is adding that.
Yes, sir.
okay, could you repeat the question?
So my question is, like now we are keeping 6.8 meter cube per hour. That you suggested 110 KLD of capacity of ETP, right?
Yes.
So whether is it sufficient for considering all these non-continuous flow effluent?
Yes.
Because
Okay, anyway, your question is valid. I have assumed, I said, I mentioned briefly saying it is an operational issue. Let's take this water rinse 2. Okay, the other things are 3-4 KL. Let's take water rinse 2, which is 28 KL, and alkali degreasing, which is 42 KL. Now this is fortnightly. So this is also fortnightly, water rinse 2 and DM rinse 3. Now, if somebody is opening both on the same day, then my maximum will be 59 KL, 60 KL.
yes,
That is why I said if I lower the collection tank volume by 70 KL, then I can pump this, even if it is on the same day. Or if they take it on alternate days, it is that much safer. Okay, the other option is have another 100 KL separate tank and then dump these things, which I feel is not required. Because the
So you
previous,
cannot assume alternatives. It can come on the same day.
yeah, even if it,
20 years can come on the
see,
same
this
day.
is how I looked at it. Even if it comes on the same day, it is only 59 KL. So the previous day, if they work and empty the tank up to 70 KL, then they can store it. Now, okay, this is a decision you have to take. You can have another 100 KL extra tank. There is no problem. But then this rinse water should, dump rinse water should not be mixed with the chemical water. Because if the same tank is used for the chemical and the rinse water, then you will have a lot of contamination issues. Because you cannot empty the tank fully. There will always be at least 1 feet of water left. So, you can have another 100 KL tank for the rinse water dump. But you don't need to have, that is my point of view, if they operate efficiently. But the choice is yours. Okay, I will do one thing. I'll just, it's only a civil plus a pump, that's all. I will add it here, and then I will in the flow diagram dump rinse water and the number dump add பண்ணிருக்கோம் high TDS dump. Okay, the high TDS dump I have given 38 KL. That is, maybe I will make it 50. That is taking into account this 42 KL. Only based on this, we have given 38 KL as ETP3 high TDS 1. I will make it 50. So that one dump can be fully handled. And this happens once in a quarter. This is the one. Hello? Repeat that. Hello? Gilia? Huh? எங்க போயிடுது
இது இந்த மெயில் தான் இதில் தான் டைம் லைன் டைம் ஏதாவது வச்சுருப்பாங்க.